Oracle Autonomous AI Database 26 AI. Free container image on Windows 11 to 10. By Docker and WSL2. Don't be intimidated by the name. This is the same version of Oracle database, but with AI capabilities added to it. This naming does not mean that this version is dedicated solely to AI, but rather has all the other features of Oracle database and can be used by regular database users as well. Look at this picture. There are many layers in the picture. All these layers will be explained in detail in the following pages.
The descriptions on the pages are complete and detailed. Such pages are marked with a symbol in the bottom right corner. If you know the material or don't have the patience or time, skip ahead as far as this icon appears.
Oracle Autonomous AI Database 26 AI. It is an autonomously managed Oracle database. Autonomous database does not require database administration. Oracle manages everything for you so you can focus on your data. Oracle offers customers cost-optimized and high-performance versions of Oracle Database, the world's leading converged, multi-model database management system. Oracle Autonomous Database, available in Oracle Cloud Infrastructure or on-premises via Oracle Cloud at customer and dedicated region or free container image, enables customers to simplify relational database environments and reduce management workloads. Oracle Autonomous Database eliminates the complexity of operating and securing Oracle database, while giving customers the highest levels of performance, scalability, and availability. With Autonomous Database you do not need to configure or manage any hardware or install any software. Autonomous Database handles provisioning the database, backing up the database, patching and upgrading the database, and growing or shrinking the database. Autonomous Database is a completely elastic service. It offers automated patching, upgrades, and tuning, including performing all routine database maintenance tasks while the system is running, without human intervention. At any time you can scale, increase or decrease, either the compute or the storage capacity. When you make resource changes for your autonomous database instance, the resources automatically shrink or grow without requiring any downtime or service interruptions. Autonomous Database is built upon Oracle Database, so that the applications and tools that support Oracle Database also support Autonomous Database. These tools and applications connect to Autonomous Database using standard SQL*net connections. The tools and applications can either be in your data center or in a public cloud. Oracle Analytics Cloud and other Oracle Cloud services provide support for Autonomous Database connections. Autonomous Database support Oracle SQL and is compatible with existing applications that support Oracle Database. With Autonomous Database you do not need to configure or manage any hardware or install any software. Autonomous Database handles provisioning the database, backing up the database, patching and upgrading the database, and growing or shrinking the database. Autonomous Database is a completely elastic service. Oracle Database fully supports schemaless application development using the JSON data model to increase developer productivity. Use Oracle Database API for MongoDB to develop and run MongoDB applications with Oracle Database on-premises and in the cloud. Customers with applications that are dependent on specific Oracle Database versions, have complete control over the versions they run and when those versions change. Develop scalable AI-powered apps with any data using built-in AI capabilities. Use your choice of large language model, LLM, and deploy in the cloud or your data center. Autonomous Database also includes the following. Oracle Apex, a low-code development platform that enables you to build scalable, secure enterprise apps with world-class features. Oracle REST Data Services, ORD's a Java Enterprise Edition-based data service that makes it easy to develop modern REST interfaces for relational data and JSON document store. Database Actions is a web-based interface that uses Oracle REST data services to provide development, data tools, administration, and monitoring features for autonomous database. Oracle Machine Learning is a set of components supporting data scientists, ML engineers, and data analysts, as well as SQL, R, and Python users. Components include SQL, R, and Python APIs, a built-in notebook interface, and no-code interfaces for AutoML, data and model monitoring, and model deployment, along with model management, deployment, and monitoring via REST endpoints. Customers with applications that are dependent on specific Oracle database versions have complete control over the versions they run and when those versions change. Autonomous Database easily migrates from MySQL, Amazon AWS Redshift, PostgreSQL, SQL Server, and other databases. A free container image for Oracle Autonomous AI Database. It's an alternative way to run autonomous database instances using a container in your own environment, without requiring access to Oracle Cloud Infrastructure Console or the Internet. Try the new innovations on 23AI or use 19C for your ongoing development. It lets you explore autonomous database features in a local, isolated environment with support for built-in database tools such as Database Actions, Oracle REST Data Services, ORDS, Oracle Apex, and Oracle Database API for MongoDB. You can access the autonomous database free container image from a repository and run it in your local environment. There are multiple locations where you can obtain autonomous database free container image, including Oracle Cloud Infrastructure Registry, Container Registry, and GitHub. The free autonomous database container image requires a Linux operating system and cannot be used on Windows, so we need WSL. To use software that requires a Linux operating system on a Windows machine, you can utilize the Windows Subsystem for Linux, WSL. WSL allows you to run a Linux environment directly within Windows, eliminating the need for a separate virtual machine or dual boot setup. This enables you to use Linux command line tools, applications, alongside your Windows environment.
Install WSL2. So in this R project, we need the latest version, which is WSL2. WSL2 uses virtualization technology to run a Linux kernel inside of a lightweight utility virtual machine, VM. To install WSL2, you must first enable essential Windows features. Since WSL2 relies on virtualization technology, it requires the Windows subsystem for Linux and virtual machine platform to be enabled. We should do these. Turn Windows features on or off, search for it in the Start menu. Enable both Windows subsystem for Linux and virtual machine platform. Restart your computer when prompted. Turn Windows features on or off is a utility within the control panel that allows users to enable or disable optional features and components of Windows. We can access it by searching for it in the Search panel. You can access Search panel via the search box on the taskbar, or by pressing the Windows key and S. So go to Install WS2. Press the Windows key and S. Press Windows key and S to open the search box and search for the Turn Windows Features On or Off tool. This is Search panel. Paste or type Turn Windows Features On or Off. Click to open Turn Windows Features On or Off tool. Enable number 1. Enable number 2. Click OK. Restart your computer when prompted. Install WSL2. The virtual machine platform in Windows 11 is a subset of Hyper-V. It's a specific component that enables the virtualization capabilities required for features like Windows Subsystem for Linux, WSL, and Windows Subsystem for Android. While Hyper-V provides the full suite of tools for creating and managing virtual machines, the virtual machine platform provides the necessary virtualization support for certain Windows features. Hyper-V, a full-featured virtualization platform included in Windows 11 Pro and higher editions, though it can be installed on home editions as well. It allows you to create and manage multiple virtual machines, each with its own operating system. Virtual Machine Platform, a specific component within Hyper-V that enables virtualization support for certain Windows features. It's required for WSL to function and may be necessary for other applications. So far, the preparations for installing your WSL2 have been made. Install WSL2. Now we can install WSL2, open PowerShell or Windows command prompt in administrator mode by press the Windows key and S, to open search panel. Right-clicking and selecting Run as administrator, enter the WSL install command, then restart your machine. For this we should do the followings. Press the Windows key and S to open Search Panel. This is Search Panel. Type or paste PowerShell or command prompt. Click to open Windows PowerShell. This is Windows PowerShell. Type WSL-install then press Enter. Install WSL2, continued. The install command performs the following actions. Downloads and installs the latest Linux kernel. Sets WSL2 as the default WSL. Downloads and installs the Ubuntu Linux distribution. Reboot may be required. Launching Ubuntu. Creating a default Unix user account. I create user Mosin with password 1. Install WSL2, continued. WSL2 uses virtualization technology to run a Linux kernel inside of a lightweight utility virtual machine, VM. Lightweight utility virtual machine refers to a specific type of virtual machine which is designed for a specific purpose and differs from traditional virtual machines. It's optimized for utility tasks like the virtual machine used by Windows Subsystem for Linux 2, WSL2, with a minimal footprint and fast startup. It's optimized for integration with the host operating system, Windows, offering faster boot times and a smaller resource footprint. This contrasts with traditional VMS that are isolated and resource-intensive. Install WSL2, continued. WSL2 uses virtualization technology to run a Linux kernel inside of a lightweight utility virtual machine. Individual Linux distributions like Ubuntu, Debian, Fedora, and Arch Linux and etc. run as container-like instances inside of the WSL2 managed VM. Each Fedora or Debian or Ubuntu version is called a Linux distro. Now we have Windows, Ubuntu, Fedora, and Debian at the same time. Use them simultaneously. Download and install the latest version of Docker Desktop for Windows. For work with containers we need Docker Desktop, the #1 containerization software. Docker Desktop is a software platform that provides a set of commands to manage the life cycle of containers, including creating, running, stopping, and removing them. Containers are lightweight, isolated, and portable packages of software that contain all of the necessary elements to run in any environment. Dependencies such as specific versions of programming language runtimes and libraries required to run the software services, binaries, configuration files, frameworks, runtimes, system tools, system libraries, and settings into a single lightweight executable package. It's a lightweight, portable, and self-sufficient unit that isolates the application from the underlying system, simplifying development, testing, and deployment. Download and install the latest version of Docker Desktop for Windows. Docker Desktop leverages the Windows subsystem for Linux 2, WSL2, backend to run its container engine. This backend operates within its own dedicated WSL distribution, named Docker Desktop. This Docker Desktop distribution functions like any other WSL distribution, adhering to the same isolation principles. The Docker engine, Dockered, and other services necessary for managing containers run within this isolated environment. While Docker Desktop operates within its own Docker Desktop WSL instance, it can interact with other installed WSL distributions if the Docker Desktop WSL integration feature is enabled in settings. This integration allows Docker CLI commands to be executed directly from other WSL distributions, seamlessly interacting with the Docker engine running in Docker Desktop. Download and install the latest version of Docker Desktop for Windows. This architecture provides the benefits of WSL2's performance and Linux kernel compatibility while maintaining the isolation and management capabilities offered by Docker Desktop. For installing the Docker Desktop on Windows, go www.docker.com. Download the installer using the download button at the top of the page, or from the release notes. Double-click Docker Desktop Installer.exe to run the installer. By default, Docker Desktop is installed at c:\program files\docker/docker. When prompted, ensure the Use WSL2 instead of Hyper-V option on the configuration page is selected or not depending on your choice of backend. Follow the instructions on the installation wizard to authorize the installer and proceed with the installation. When the installation is successful, select Close to complete the installation process. Now we start downloading and installing Docker Desktop by going to www.docker.com. Do as you are shown. 1. Left-click on this. 2. Right-click on this. 3. Click on Copy link to start the download. Minimize this background window to make the main window more visible. Click OK. Click OK to start download. Download is in progress. Download is complete. Click Open to start the installation. Start installing Docker Desktop. Check all three options and finally click OK. Installation is in progress. Installation is complete. Click Close to end the installation process. Docker Desktop icon in My Start menu. Pin Docker Desktop icon to Start menu. Docker desktop icon is in my start menu now. Click on it to run Docker desktop. If you on Docker desktop for the first time, you see this page. Select accept. I use Docker by my personal email. And then press continue. Tick this and then press open button. It is Docker desktop in Windows. Docker desktop for Windows. Start Docker desktop. Docker desktop includes an integrated terminal within its dashboard interface. This integrated terminal allows users to interact directly with their running containers and the Docker environment without needing to open a separate command line interface. Docker desktop for Windows. Docker desktop includes an integrated terminal within its dashboard interface. This integrated terminal allows users to interact directly with their running containers and the Docker environment without needing to open a separate command line. Here's what you can do with the integrated terminal in Docker desktop. Run commands within a running container. You can execute commands inside a specific container, just as you would with docker execit/bin/sh or docker execit command exe for Windows containers. This allows for debugging, inspecting, and managing processes within the container. Access logs and information. You can view logs and other details about your running containers and Docker environment directly from the terminal. Basic terminal functionalities. The integrated terminal supports common terminal features like copy, paste, search, and clearing the session. Session persistence. Your terminal session persists even if you navigate to other parts of the Docker desktop dashboard and then return to the terminal view. Streamlined workflow. It reduces the need for context switching between the Docker desktop GUI and external command line interfaces, enhancing developer productivity. Click here to open terminal. This is the integrated terminal.
Now we are in integrated terminal. Type this command and press enter. The docker run command creates running containers from images and can run commands inside them. This command runs AAIDB in a container. The container name is AAIDB. You can choose any name you want. This command creates a database in the AAIDB container. The name of this database is myATP. You can choose any name you want. The database name must contain only alphanumeric characters. If not provided, the database is named myATP or myADW, depending on the type of workload submitted. The workload of this database is ADP. The work type, workload_type, can be ADP or ADW. The default value is ADP. The autonomous database supports different workload types, including autonomous data warehouse and autonomous transaction processing. Each of these workload types provides performance improvements and additional features that support operations for the specified workload.
I type the command and press enter.
When running the Docker command, it first looks locally for a previously downloaded image. If no such image exists, it indicates that Docker cannot find the specified image in its local image cache. As a result, it attempts to download the image from a configured registry, which is usually Docker Hub by default. To see the containers, click here. Click on the AAIDB link to enter our container. We are now in AAIDB container, then we can view information about our container including logs, and files, and even access the shell by selecting the Exec tab. Containers can organize information using tabs, effectively categorizing data into distinct sections. These tabs allow users to switch between different views or sets of related content, improving navigation and user experience.
Starting an ADB-free container. It is necessary to change the admin_password upon initial login. Ensure you check the following requirements when you create or modify the admin_password. The password must be between 12 and 30 characters long and must include at least one uppercase letter, one lowercase letter, and one numeric character. The password cannot contain the username. The wallet is generated using the provided wallet_password. Ensure you check the following requirements when you create or modify the wallet_password. The password must be between 8 and 30 characters long and include alphabetic characters combined with numeric characters or special characters. For an OFS mount, the container starts with sys_admin capability. Also, virtual device/dev/fuse must be accessible. This P options specify that the following ports are forwarded to the container process.
This structure is what we have provided you so far. Now, we have an Oracle Autonomous AI database called MyATP with an ADP workload inside an AAIDB container. Next, we will go into the settings and configuration of MyATP in a Windows environment. AAIDB container platform for maintaining, running, and isolating my Oracle database. Docker Desktop runs within its own dedicated WSL distribution, Docker Desktop. We are now in Exec tab. This tab allows you to quickly open an interactive terminal session directly within a running container. You can execute commands within the container's environment, similar to using the Docker exec at ADB free date. Command in a command line interface. We have now MyATP database. If you want have another workloads database, you can add a database using the add database command. ADBCLI add database workload type ADW admin password welcome_1234. This is optional, so I cancel it.
To change password for admin user, use the following command. ADBCLI change password database name myATP old password welcome_1234 new password welcome_12345. We go File tab and go to this path. /u01//oracle/23.0.0/home_1/network/admin/. The listener and sklnet are there, but the tuncenames.ora file does not exist. So we need to create it. To do this, we need to go to the Exec tab. We go Exec tab and type this command. cat/u01//oracle/23.0.0.0/home_1/network/admin/. Press enter. Cat command creates the file and wait till we enter content of file. We will enter contents in next phase, so press Ctrl+D to finish cat command. We go File tab and go to this path. /u01//oracle/product/23.0.0.0/home_1/network/admin/. Right-click on tuncenames.ora file and select Edit. There is no content for the tuncenames.ora file in the editor. Next, I will show you how and where to copy the appropriate content into this file. We go Files tab and go to this path. Right-click on tuntsnames.ora file and select Edit. Copy the entire contents of this file with Ctrl+C, 39 lines. Let's go back to the file we created with the cat command, which was empty. Right-click on tuntsnames.ora file and select Edit. Press Ctrl+V to paste everything we copied from the other file with Ctrl+C into this file, and press the Save and Exit key. Save the file and exit.
Connecting to Oracle Autonomous AI Database. Available TNS aliases. Use any one of the following aliases to connect to a DB-free container. MyAdP TNS aliases. MyAdW TNS aliases. TNS alias mappings to their connect string can be found in $TNS_admin/tuntsnames.ora file.
SQL+. Navigate to Exec tab. Use the following command. We connect using the alias myatp_low. If that doesn't work, use myatp or myatp_low_tls.
Keep in mind the order of the numbers. 1, 2, 3, 4.
To connect to SQL+ from your host terminal, you can use the docker exec command. This command allows you to execute a command within a running container. Connecting to Oracle Autonomous Database. Container hostname is used to generate self-signed SSL certs to serve HTTPS traffic on port 8443. Apex and database actions can be accessed using the container host, or simply localhost. To access Apex https://localhost 8443/ords/apex. To access database actions https://localhost 8443/ords/SQL developer. Note: for additional databases plugged in using adbcli add database command, please use the URL formats https://localhost 8443/ords/database_name/apex. https://localhost 8443/ords/database_name/SQL developer. To access Apex and database actions respectively.